All right, so I'm going to change this problem. So the interval I want us to use is between 0 and 6. All right, so this is a parabola, and I know if I factor an x out, I get x minus 2, so that gives me an idea of what the parabola looks like, right? Crosses here at 0 and 2. So if I'm using left-hand endpoints with 6 subintervals, the delta x will be, oh, look at that, nice 1. All right, so my first rectangle will go between 0 and 1. There's rectangle 1, rectangle 2, and then rectangle 3, 4, 5, and 6. Okay, so 3, 4, 5, and 6. So those are the edges for my rectangles. So rectangle 1 using left-hand endpoints, between this edge point and this edge point, there it is, that's the rectangle. Rectangle 2, between these two edge points, I'm using the left-hand endpoint, there it is. Rectangle 3, left-hand endpoint, it's giving me this again. Left-hand endpoint for rectangle 4 gives me this. Left-hand endpoint for rectangle 5 gives me this, continuing the function out. And left-hand endpoint for rectangle 6 gives me this. All right, so L sub 6. So the width of each rectangle is 1. So the left-hand endpoint gives me f of 0 plus width of the rectangle is 1, f of 1, and then f of 2, f of 3, plus 1 times f of 4, plus 1 times f of 5. So these are 1, 2, 3, 4, 5, 6 rectangles I'm finding the area of. So when I put in 0, I get 0. Plus, when I substitute 1 in, I get negative 1. And then put 2 in here, so I get 4 minus 4. That's giving me the 0 again. Plus 3, so I get 9 minus 6. 16 minus 8. And 25 minus 10. So let's see what I've got here. So I get negative 1, that goes to 0, and there's another 0. This gives me a positive 3, plus an 8, plus a 15. So this is giving me a positive area. So I have 11, subtract a 1 is 10. So I get an area of 25. So you can see these black areas that are above the x-axis, these areas of these rectangles here, are more than the negative areas under the curve, under the x-axis. So that's why we get a positive quantity. All right, so this is the big deal. Definition of the definite integral is this: limit of the sum, height of the rectangle, width of the rectangle, and it gives us this integral from a to b. All right, so now we know that that's what this means. This means the exact area under the curve, not just the finite number of rectangles. This is just the Riemann sum. So this, what we've done here, is just this part, right? Now we get to take the limit of and let the number of rectangles go to infinity. That will give us the exact area under the curve. So we'll dig into this next example on the next video.